Today, we're diving into something that could, and I mean really could, fundamentally change how we understand biology and create new medicines. We're talking about AlphaFold 3. Okay, so picture this. Inside every single one of your cells right now, there's this incredible invisible dance happening. A whole universe of molecules is in constant motion, interacting in ways that literally determine your health, that define life itself. And for decades, seeing this dance, it was pretty much impossible. So to even begin to understand this universe, scientists had to start with the biggest players on the stage, proteins. And that, right there, is where the story of AlphaFold really kicks off. You probably remember this. Just a few years back, AlphaFold 2 burst onto the scene. And it was a monumental achievement. It solved this 50-year-old grand challenge in biology, predicting a protein's 3D shape just from its genetic code. It gave us our first really clear pictures of these workhorses of the cell. But here's the thing, right? Life isn't a solo performance. Proteins almost never work alone. The real magic, the stuff that actually makes biology, biology, that happens when proteins interact with everything else. We're talking DNA, RNA, and even the tiny molecules we use as drugs. So predicting all of those complex interactions, that was the next great challenge. The problem was the tools we had were all super specialized. It was like having one toolbox just for proteins and DNA, another one just for proteins and drugs. And they often weren't very accurate anyway. What we really needed was one single tool that could see the entire ensemble all at once. And that's exactly where AlphaFold 3 comes in. Now, don't think of this as just an upgrade, like an AlphaFold 2.5. No, this is a completely new approach, rebuilt from the ground up. So, at its core, AlphaFold 3 has a totally new engine. You see, the old version, AlphaFold 2, it leaned heavily on looking at evolutionary history, like comparing blueprints from related molecules. AlphaFold 3 reduces its reliance on that. But the real game changer is how it actually builds the final 3D structure. Instead of predicting specific little angles and putting it together piece by piece, this new diffusion module generates the raw positions of all the atoms for all the molecules all at once. It's a whole new way of thinking. So, how on earth does that diffusion thing work? Well, the best way to think about it is like a sculptor, but working in reverse. The AI starts with just a random cloud of atoms, total noise, a blurry mess. Then, step by step, it denoises this cloud, refining the positions, making it a little clearer, a little more accurate. It just keeps doing this over and over until a precise, final 3D structure literally emerges from the noise. It's this incredible generative process, going from total chaos to perfect clarity. Okay, so that all sounds pretty amazing in theory. But the big question is, does it actually work? How well does this new engine perform in the real world? Well, the results are kind of stunning. Let's dig into the numbers. All right, first up, predicting how a potential drug binds to a protein. This is absolutely critical for drug discovery. The traditional tools used for this, they get it right about 42% of the time. Not bad, but Now look at AlphaFold 3. It nails it almost 69% of the time. That is a huge leap in accuracy, a massive improvement. And it's the same story when we look at how proteins interact with DNA and RNA, the interactions that are crucial for controlling which genes get turned on or off. The specialized tools designed just for this one job scored around 53 on this accuracy metric. AlphaFold 3, it comes in at 67. Again, it's not just better, it's way better than the tools that were supposed to be the experts. And check this out, because this one is a really big deal. Predicting how an antibody grabs onto an invader, like a virus, that's one of the toughest problems in this field. Even the last version of AlphaFold, which was already pretty great, only got it right about a third of the time. AlphaFold 3 jumps that success rate all the way up to nearly 50%. That is a massive, massive improvement over its own predecessor. The researchers who built it put it perfectly in their paper. They said that these results show that for the first time, it's possible to accurately model pretty much the entire world of biomolecules, all within a single AI framework. This isn't just a small step forward, folks. It's a whole new ballgame. So, okay, this is all incredibly cool for scientists, but this is not just some academic exercise. This breakthrough has profound, and I mean profound, implications for the future of medicine, for all of us. I mean, just think about it. What if we could design drugs way faster and with much higher confidence that they'll actually work? What if we could see the exact molecular glitch that causes a specific genetic disease? We could finally unravel how all the tiny machines in our cells actually work together. By giving us this incredibly detailed map of our inner world, AlphaFold 3 could just dramatically accelerate all of this. Okay, but let's be real for a second. No tool is perfect, right? And it's super important to understand the limitations here, to know what AlphaFold 3 can't do, at least not yet. So the researchers themselves are really upfront about this. Sometimes the model can get the molecular handedness wrong, producing the left-handed version instead of the right-handed one, which can be a big problem in biology. And because it's a generative model, it can sometimes hallucinate, inventing a structure that looks totally plausible but is actually wrong. But maybe the biggest thing to remember is that it gives us a single static picture, a snapshot in time. It doesn't show us the dynamic movement of these molecules. These are definitely the next big hurdles to clear. But look, even with those limitations, there's no question, this is a monumental leap forward. It's a huge step towards finally being able to unravel the full, honestly, dizzying complexity of biology right down at the atomic level. We are getting so much closer to having that complete blueprint of life. So, what does this all mean? Well, having the ability to see these fundamental interactions in such detail, it moves us from just being observers of biology to potentially becoming engineers of it for the good of human health. It's like for so long we've just been trying to read the book of life. Now, we're starting to figure out how to write brand new sentences. The next chapter, it's just beginning.